In this series of lessons, we're going to be learning how to evaluate inverse trig functions. Now, before we get into the inverse trig functions, I want you to think about some pretty simple algebra problems as you see over here. 3 times x equals 9 and x minus 2 equals 10. Now, if I asked you to solve for x in either of these two problems, I think you probably know the answer, obviously, but I want you to think about what you would do in order to solve for x. In this case, I take 3 times a number and it equals 9. If I want to find out what that number is, what x is, I try to get it by itself. Well, you'd probably tell me, well, you just divide both sides by 3. And you'd be correct in saying that x is equal to 3 then. Now, why did you divide? Well, you divided by 3 because in the original equation you took 3 times x. You were using multiplication. And to undo multiplication, you use an inverse operation. Division is the inverse of multiplication. It undoes whatever the multiplication may have done in the first place. So I perform an inverse operation to both sides. I get my variable by itself and I get an answer. Same here, 5x minus 2 equals 10. Well, I'm subtracting. The inverse operation would be addition. So I add 2 to both sides and x is equal to 12. Now here I have an example of a trig equation. The sine of theta is equal to 3/5. An expression I might have gotten by looking at a right triangle like the one you see here, where theta is down in this corner, 3 is the opposite side, 5 is hypotenuse. Now if I wanted to figure out, well, what is the measurement of angle theta, this is the equation that I essentially have to solve. I know the sine of whatever that angle might be is equal to 3/5. So how do I solve for theta? Well, what I'm going to do is I'm going to perform an inverse operation. Instead of taking the sine of theta, I'm going to take the inverse sine of that expression. Now the inverse sine, a little sign with a -1, is a button that's on your calculator. And that's what we're going to be using a lot today. So the inverse sine undoes the taking of sine. It's kind of like dividing this side by 3. 3 divided by 3 is 1. Inverse sine of sine goes away, I'll have just theta. And if I do something to one side, well, I better do the same thing to the other side. So theta is equal to the inverse sine of 3/5. Now when I say inverse sine, that's what it is. It's the inverse sine function. Another name that we'll often hear is the arc sine. Okay? So this is inverse sine or arc sine. So if I say either one of these things, that's going to mean the same thing. So let's get it to work here. Problem presented to us here says, in 1906, Teddy Roosevelt designated Devil's Tower National Monument, pictured there, in northeast Wyoming as the first national monument in the United States. The tower rises 1,280 feet above the valley of the Belfourche River. So our problem here is that if the shadow of the tower is 2,100 feet long at a certain time, find the angle of elevation to the sun. Well, anytime I have a word problem that involves trig, or word problems in general, it's a good thing to draw a picture. So what I'm going to do is I'm going to draw, here's Devil's Tower, which is this big structure, goes straight up. And then I've got the sun here, somewhere up above. And the sun is shining down and it's casting a shadow. So here's my shadow at the bottom of the valley. Now, I'm told a couple of things. I'm told that the shadow is 2,100 feet long. I'm going to turn this into a right triangle here. The shadow is 2,100 feet long from the base, and Devil's Tower is 1,280 feet above the valley. So that means this side is 1,280 as I think about my right triangle that I have here. I'm asked to find the angle of elevation of the sun. Well, here would be my angle of elevation looking back up towards the sun. So let's think about when I'm trying to find an angle. That means I need to use inverse trig here. So, compared to theta, which two sides do I know? Well, I know that the side opposite theta is 1,280, and I know the side adjacent to theta is 2,100. Opposite and adjacent is tangent. So I know that the tangent of theta is equal to the opposite side over the adjacent side. So there's the trig equation that I'm going to set up based on the information that's given to me. Now I solve. Instead of taking the tangent, I'll do the inverse. The arctangent, or the inverse tangent of both sides. So theta is going to equal the arctangent of 1,280 divided by 2,100. This being an expression that I would then type into my calculator. Here's how I would do that. Cleaning up what came before. The inverse tangent is little tan with a -1. It's above tangent itself. So I'm going to use the inverse tangent of, if I type my fraction, 1,280 divided by 2,100. Close the parentheses. Now, I would like a degree measurement in this case, so I need to make sure my calculator is in degree mode, which it is. Quit, go back to the problem. I'm ready to go. I hit enter. I get 31.36. So I'm going to write that down as my answer. 31.36 degrees is approximately the angle of elevation we have looking up at the sun based on the information that's given to us. Now, does that sound like a reasonable number? I'd say so. Another similar problem. Using a rangefinder, tourist estimates the top of the tower to be 4,000 feet away from where he's standing. At what angle is the tourist holding his rangefinder? So, quick picture of what's going on. Again, here's the tower. It's 1,280 feet. That didn't change. This time, I don't know the shadow or anything like that, but apparently this tourist standing down at the bottom is looking up at the top, and he figures out that the top is 4,000 feet away from him. So, now what angle is he holding his rangefinder? Well, we're still going to find this little angle in the corner, the same angle of elevation, but now we've got some different numbers going on. So, compared to theta, the sides that I know the opposite side, I know the hypotenuse. Opposite hypotenuse, that goes with sine. So I write out that the sine of theta is equal to the opposite side over hypotenuse. Solving for theta, I want to find the angle, so I'm going to use the inverse of sine on both sides, of course. So theta is equal to the arc sine of 1,280 divided by 4,000. Again, that's an expression that can be typed into my calculator. Arc sine of 1,280 divided by 4,000. Oops, too many zeros. Close parentheses. I was in degree mode from before. I hit enter. There we go. 18.66 degrees is a good looking answer. So as we keep going, a couple more problems. A little multiple choice. What's the measure of the angle theta in the triangle that's shown to us? Well, what sides do I need this angle? What sides do I know? Compared to that angle, I know the adjacent side and the hypotenuse. Adjacent and hypotenuse, those go together in cosine. So my initial equation says that the cosine of theta is equal to 6 over 11. I'm going to solve by taking the arc cosine this time. So theta equals the arc cosine or inverse cosine of 6/11. Once again, that's something I type into my calculator. Second cosine, 6 divided by 11. Hit enter. 56.94 degrees. Is that one of our multiple choice options? You bet it is. 56.9. So C would be the answer there. Write that as well. Now, the last problem that we'll look at in this little video. Fire truck has a 100-foot ladder whose base is 10 feet above the ground. Firefighter extends the ladder toward a burning building to reach a window 90 feet above the ground. So, a couple things I'm going to draw. Draw a diagram. Here's the building. So the building itself, from top to bottom, is 90 feet tall. And then I've got this fire truck. Draw ourselves a fire truck here. Pretty rough, but you get the idea. There's a fire truck. And it's got a ladder that extends up to this burning window. So the ladder is a couple things. The ladder itself is 10 feet above the ground, first of all, which we're going to need to take into account a little bit. And this burning window to which it's reaching, well, that's the 90 feet up. The ladder is 100 feet long, so I'll label that. And we're supposed to ask, at what angle should the firefighter set the ladder? So what's this angle right here? Now, if I use that angle and draw myself a right triangle, the right triangle really is at the top of the fire truck. Now what that means is I got to change some side lengths. This isn't quite going to be the full 90 because I start 10 feet off the ground, so really this side of my right triangle is only 80 feet. So I'm trying to find this angle. I know 80 feet, which is the opposite side. I know 100 feet, which happens to be the hypotenuse of this right triangle. Opposite hypotenuse, that's sine. Sine of theta is equal to 80 over 100. We take the arc sine of both of those. We're going to have theta equal to the arc sine of 80 over 100. Typing that in the calculator. Second side, 80 divided by 100. Hit enter. 53.13 is our answer. So we'll jot that down here. 53.13 degrees. So those are several examples of using inverse trig functions to find missing angles in given problems.